SwayamPrabha. Digital India. Educated India.
Good morning and welcome to this next lecture on vibrations of plates and shells. We are now in the forced response section. And we have a simply supported plate. So we have looked at a couple of responses. The next one is a point moment. Okay, next one is response of a simply supported plate to a point moment, point harmonic moment. Okay, so let's see if this is my geometry. And I am going to align the moment diode, along this direction. It means it will be like this, oscillating. So how do we accomplish that? So in this direction it is at y star. Let this be B. Let this be A, and in this direction it is at y star. So I need a description. Q3 x comma y comma t. Okay, one thing is it's in the direction y at y equal to y star. Okay, then what? I will accomplish it using two forces. So, and here let's say it's at x equal to x star. So I will put a force at x star minus delta x by 2 and a opposite force at x star plus delta x by 2. So I have delta x minus x star minus delta x by 2 minus, this force is the other way, delta x minus x star plus delta x by 2. Okay, and then the amplitude is f. Force amplitude is f and f. So I will put an f here. Okay. Now in order to make it a point moment, delta x has to go to 0. Delta x must go to 0. Okay. And I need a moment strength in front. In place of this, actually I need a moment strength. Okay. So how do I do that? So I will take delta y minus y star here, f here, multiply by delta x. Now that is a moment. Then I have delta x minus x star minus delta x by 2 minus delta x minus x star plus delta x by 2. and I will divide this by delta x and take the limit delta x tending to 0. Now as delta x tends to 0, I will adjust the force magnitude such that this ends up as the moment strength I want, okay. And this term is the derivative of the delta function at x star. So how does it look finally? My q3 x comma y comma t is m delta dash x minus x star delta of y minus y star and harmonic. I forgot that the harmonic term here. Okay, and let us see the units. Units has to be force per unit area, okay, that can't be avoided. So this is a moment, so force into length, okay. Delta dash has now 1 over length squared and delta y has 1 over length. So this goes, this is force in over per unit area units. So we are okay. Okay, so units are okay and descriptor is okay. So now we have to find as usual the FMN. Okay, that is 1 over rho h n mn, which is AB by 4 for a simply supported plate, then integral 0 to A, integral 0 to B, m delta dash x minus x star delta y minus y star into the mode shape sine m pi x by A sine n pi y by B dx dy into, okay. So the y integral is simple. So what do we have? I have 4 by rho h a b m, okay, into sine n pi y star by b, then remaining 0 to a delta dash x minus x star sine m pi x by a dx. Okay. So now this we will use the product rule. So that ends up as 4 m by rho h a b sine n pi y star by b. Okay. Now the first term here is sine m pi x by a delta x minus x star 0 to a minus integral 0 to a, the integral of the first one, sorry, delta x minus x star and the derivative of the second. So m pi by a cos m pi x by a dx. So now this term here, let us look at 1 over here. 1 is sine m pi x by a x minus x star 0 and a. Okay. Now we are not putting a force at the boundary at 0 or a, we are putting a force somewhere in the medium in the plate. So x star will never be 0 or a. So this delta function argument is not 0, and if I substitute either a or 0 here, this term is 0, sign is 0. So this term is 0. So I am left with this term. Okay. So if we go to the next page, this is a delta function, so delta function properties will straight away hold. So what we have now is Fmn or Fmn star, I think. Let's call it Fmn star as before. Fmn star is equal to minus 4m by rho h ab into m pi by a into cos m pi x star by b into sine n pi y star by b. Okay. Then of course gamma mn is f mn star divided by omega square mn minus omega square plus j twice zeta mn omega mn omega, and from here we get eta mn as gamma mn e to the power of j omega t, and then w x comma y comma t. Let me write it. W x comma y comma t is double sum n minus 4m by rho h a b m pi by a cos m pi x star by a sine n pi y star by b omega mn square minus omega square plus j 2 zeta mn omega into sine m pi x by a into sine n pi y by b into e to the power j omega t into e to the power of j omega t. All this in the numerator. All this in the numerator. Okay. So now let me remind you that point moment. This was pressure and this was point force. So here is the point force response of a simply supported plate. This m argument or n argument nowhere there as separate in the numerator or denominator. That's response to a point force. Okay. And so we say it prefers all modes equally. Then we looked at response to pressure. What happened in pressure? We got mn in the denominator. The mode indices product in the denominator. Okay. So therefore, if m and n go large, then the response is lower. So that means pressure prefers lower modes. Then just now we did point force, and what do we get? We get m pi by a in front and m on top. So, moment prefers higher modes. Okay. So, if you do not want to excite higher order modes in a plate, do not put moments. Okay, that is the idea. Now, we will continue. What is the next? What is the next force type that we are looking at? Okay, let us say we want to look at a rotating moment. Rotating moment. Okay. So, what do I mean by rotating moment? If the diode for a moment is like this, okay. So, you use your right hand rule and the moment is going this way. Now, the moment is rotating, okay. This diode rotates on the plate, moment rotates, the plate is sitting. So, now let me draw the schematic. So, here we are going to put the rotating moment again at x star y star, okay. But we are going to use a clever trick, which is we put a moment that was oscillating this way, and what did we have? We had a del by del x of m delta x minus x star into delta of y minus y star. Okay. So, now suppose there is a similar moment aligned the other way along the y direction like this. Okay. The other one was along x direction, this is along y direction. So, then I will have del by del y m delta y minus y star into delta x minus x star. Okay. Now, if I apportion these in terms of cosine and sine, what I mean is if I make this a cosine omega t, if I make this a sine omega t, multiply by, okay, then you should be able to see that together they represent a rotating moment. Okay. At t equal to 0, it is aligned along this, okay, and it is not aligned, it has no component along the y direction. At t such that cos omega t is pi by 2, then there is no component along this, there is a component along y direction. Okay. Similarly, if omega t goes to pi, then sine component goes to 0, and then I have an alignment along again x. Okay. And so, you can see that as time goes by, I have a rotating moment on the plate. Okay. So, there is a rotating moment here. Now, units are appropriate because moment is force into length, derivative gives me one length here, delta 2 delta x is give me 1 over L square. So, this is force over unit area. Okay. So, now if this happens to be my Q3, okay, so this is my Q3. q3x comma y comma t is equal to this summation. Okay. Then what would be my fmn? So fmn, I will keep the time this time here, is m integral 0 to a integral 0 to b, then delta dash x minus x star, delta of y minus y star, cosine omega t, sine m pi x by a, sine n pi y by b, dx dy. So let me close it here, I think, yeah. So plus delta dash y minus y star, delta x minus x star, sine omega t, sine m pi x by a, sine n pi y by b, dx dy, divided by rho h nmn, so 4 rho h ab. So what do we get? We get 4m by rho h ab. Okay. So in this case, this integral works out simple, and I will pull cos omega t out. So I have cos omega t sine n pi y star by b, then integral 0 to a delta dash x minus x star sine m pi x by a dx plus sine omega t sine m pi x star by a, here integral 0 to b delta dash y minus y star sine n pi y by b dy. Okay. From our previous experience, I will write 4m by rho h ab cos omega t sine n pi y star by b, okay, minus m pi by a cos m pi x star by a minus, okay, sine omega t sine m pi x star by a n pi by b cos n pi y star by b. Okay, if I bring this outside, minus 4m by rho h ab, okay, then I have something into cos omega t plus something into sine omega t. Okay. So if I make it this a sine phi and make this a cos phi, whereas phi is something, okay, then I have minus 4m by rho h a b a sine omega t plus phi. Okay. What is A now? A is equal to square root of sine square n pi y star by b cos square m pi x star by a into m pi by a whole squared plus sine squared m pi x star by a into cos square n pi y star by b into n pi by b whole squared. All these under the root. Okay. So then what happens? Then I have f mn of t, I will write for now as minus 4m by rho h a b a times e to the power of j omega t plus phi. Okay. So then my gamma tilde mn is equal to f mn minus 4m by rho h a b a e to the power of j times phi. Okay, into e to the power of j omega t. We will keep in the league of gamma mn for harmonic, we will keep it out. Okay, a e to the power j phi divided by the frequency term omega mn square minus omega square plus j2 zeta mn omega mn omega. Okay, that is gamma tilde mn. Okay, then what? Then I have eta mn. Okay, so eta mn now is gamma tilde mn e to the power j omega t. Okay, so that is minus 4m by rho h a b a e to the power of j omega t plus phi divided by this frequency term. Okay. Then finally what? Finally we have w x comma y comma t is double summation eta mn sine m pi x by a sine n pi y by b. Okay, but the actual forcing was sine part of it. Okay, so my response now is the imaginary part of w of x comma y comma t. Okay, with this we are getting response for both cos omega t plus phi and sine omega t plus phi. Okay, but what is it actually? Actually here it is sine omega t plus phi, and therefore finally we take the imaginary value of this. Okay, that is the response to a rotating moment. Okay. So, there will be another, if we convert this to magnitude and phase, there will be another phi 2 coming in, another phi 2 coming in. Okay. So, that is response to a rotating moment. Then let us see, then we will take something simpler now, which is let us say a line force, a line force. Here I will just derive the Fmn and leave it. Okay. So, what do we have? We have a simply supported plate as always. This is my x, y and z. At some x equal to x star, let us say, I have a force which is a line force, and let it extend all the way from 0 to b. It can extend only a part length also. Okay, we have to make an adjustment for that. So, let us extend it from all the way along the length of y, b. Okay. Now, it is a uniform force. So, let us say its F star per unit length, and therefore, F star into B is the full force. Okay. So, let us take F star as F over B. So, already one length has been taken out. Okay. Further, it is add x equal to x star. So, I will multiply this with a delta that already gives me force per unit area. Okay. And I will restrict it, here it is not necessary, but I will restrict it from 0 to b. So, h y minus 0 minus h y minus b. Okay. So, if it was not from 0 to b, you will have some y1 and y2, that is the idea. So, what is my q3, q3 x comma y comma t description? It is total force over distance in the y direction located at x equal to x star between h y0 to y equal to b, and it is harmonic. Now, from here you can proceed to get your Fmn and etc. Okay. Now, the next one is, we will do it in the next class. Okay. We are just about out of time, so I will stop the lecture here. Thanks.